Welcome, guys. We are going to go back to doing our video lessons. Tonight we're going to solve equations that have rational exponents. So you're going to look at something that maybe x to the 3/2 is equal to 12, and we're going to be able to solve that. So remember, a rational exponent is just a fancy way of writing a radical. Okay, so we're going to get started. We are going to solve this for x. Figure out what x equals. We're going to check for any extraneous solutions. These are solutions that we create during the solving process that are not valid. So just like we did yesterday, my first job is always to isolate the variable. So I've got to get x all by itself. And the problem is, it's not. It's inside this thing, and it's being multiplied by 2. So my first step is I'm going to try to get this set of parentheses all by itself. So when I do this, I get x plus 3 to the 2/3 power is equal to the number 4. And now I can come over and I'm going to get rid of that. I can come over and I can use that reciprocal property we talked about yesterday. So I'm going to take this reciprocal. I'm going to take the reciprocal of 2/3. So what does that mean? Flip it. So I'm going to use 3/2 and raise each side to 3/2. So if I come over here, I'm going to rewrite this. I've got x plus 3 to the 2/3 power, and I've got 4 over here. But now I'm going to raise this side to the 3/2, and I'm going to raise this to the 3/2. And what happens when I do this? Over on this side, I get x plus 3 to the 6/6, and then I get 4 to the 3/2. Well, x plus 6 is to the 6/6 is just x plus, it's x plus 3, right? I screwed that up. X plus 3. And on this side, I've got 4 to the 3/2 power. Well, I'm going to rewrite this as a radical because I can evaluate it. And this is an index of 2, 4 cubed. So what is the square root of 4? So the square root of 4 is 2, and then I take 2 and cube it, which gives me 8. So I end up with x plus 3 is equal to the number 8, and then I solve for x, and I get x is equal to 5. Now, before we do any of this, we have to go back through and check your solution. So we want to make sure that through the process of solving, we didn't mess anything up. So we're going to substitute back in x equals 5. This is the check your work part. So we're going to take 2. We're going to plug in our value of 5. 5 plus 3 to the 2/3 power. Does that equal 8? I'm not sure. I'm just checking my work. So I end up with 2 times 8 to the 2/3 power. Does that equal 8? Well, I'm going to take the cube root of 8 and then square it. The cube root of 8 is 2, so 2 squared is 4. So I end up with 2 times 4. Does that equal 8? Yes. So my answer is x equals 5. So there is a little bit more work there. All right, let's try another one. Remember, my goal is to get this set of parentheses all by itself. So I need to get this by itself first, okay? And how do I do that? I'm going to use opposite operations. I'm going to use inverse operations. The first thing I'm going to do is add 1 to each side. So I get 5x plus 1 to the 3/4, and that's going to equal 40. But I still don't have x plus 1 by himself yet. So now I'm going to divide each side by 5. And, whoa, now I get x plus 1 to the 3/4 is equal to 8. And now I've got to go figure out my reciprocal. Well, my reciprocal, if I've got x plus 1 to the 3/4 equals 8, I need to raise each side to the 4/3 power. When I do that, 12 over 12 simplifies to 1, so I end up with x plus 1, and I get 8 to the 4/3 power, which is the cube root of 8, and that number to the 4th. So if I come over here to the side and I say, well, the cube root of 8 is 2, 2 to the 4th is what? 2 to the 4th is 16. So I get x plus 1 is equal to 16. And when I subtract, I get x is equal to 15. But remember, we have to check our work. So in order to check our work, I'm going to go grab this equation, clone it. And I'm going to see if x equals 15 makes any sense. So I'm going to take 5 times 15 plus 1 to the 3/4 power minus 1 equals 40. Is that true? So off to the side, I'm going to go ahead and work. What is, oh, I don't want to put that there. Sorry, I lost my cursor, guys. I'm working blind here. So I'm going to take 16 to the 3/4 power, which is the 4th root of 16 cubed, which is the 4th root of 16 is 2 cubed, which gives me 8. So this whole thing over here, this thing right here becomes 8. So I get 5 times 8 minus 1. Does that equal, ooh, this should be 39. Whoops, that should be 39. So does 5 times 8 minus 1 equal 39? It does. I end up with 40 minus 1. So I can say that x equals 15th is the solution to that equation. All right, let's try another one. We've seen something like him. Let's try one of these. So this presents a unique problem. What do I do here? They're both the same power. So if I square this side and I square this side, I think I'm going to square each side. But I think the first thing I'm going to do is I'm going to move this 2x plus 7 to the 1/2 power. I'm going to move it over to the other side because it's going to be easier. It's going to be a lot easier when I square it. So I now get 3x plus 2 to the 1/2 is equal to 2x plus 7 to the 1/2. And now I'm going to square each side. So now when I come through and I'm going to multiply this by the reciprocal, which is 2 over 1, 2 over 1, I end up with 3x plus 2 is equal to 2x plus 7. So that works out really nicely. So let me solve this. And I end up with x is equal to 5. Let's see, I don't know, is that true? So I'm going to go clone this, see what we get. Let's see if x equals 5 is a solution. So we are checking x equals 5. So I'm going to take 3 times 5 plus 2 to the 1/2 power minus 2 times 5 plus 7 to the 1/2 power. Does that equal 0? So 3 times 5 is 15. Does 17 to the 1/2 minus 17 to the 1/2 equal 0? It does. So x equals 5 is my answer. All right, let's go try this one. We're in that same predicament. If I can move this to the other side and then raise everything to the 5/3 power, I'm in luck. So that's what I'm going to do. I'm going to add 5x plus 8 to the 3/5. I'm going to add that to each side. I don't know what's happening. Well, you get the idea here. If I add that to each side, I end up with this. I end up with 2x plus 6 to the 3/5 is equal to 5x plus 8 to the 3/5. And now I'm going to use the reciprocal. The reciprocal is 5/3. I'm going to raise this side to the 5/3 power, and I'm going to raise this side to the 5/3 power. Well, when I do that, I get 2x plus 6 is equal to 5x plus 8. So let's solve and see what we get. I get 3x is equal to a negative 2. So x is a negative 2/3. So this is kind of going to be a pain to check, but we have to. We don't get a choice. All right, so let's figure out what we get here using x equals negative 2/3. Okay, so we're going to start substituting in. I have 2 times negative 2/3, whoops, 2 times a negative 2/3 plus 6, and that's to the 3/5 power, minus 5 times negative 2/3 plus 8. That's to the 3/5. Does that equal 0? That's what I'm not sure of. So here I get negative 4/3 plus 6 to the 3/5 minus, over here I get negative 10/3 plus 8 to the 3/5. Does that equal 0? So now I have to put some fractions together. I need a common denominator, so this has got to be over 3. So I get negative 4/3 plus 18 over 3. And over here I need a common denominator, so I get negative 10/3. This is going to be plus 24/3. So let's look. This number simplifies to 14/3. So does 14/3 to the 3/5 minus 14/3 to the 3/5 equal 0? It does. So that's my answer. X equals negative 2/3. You guys, that is it. So come to class with any questions. This is what we're going to work on when we're in class. All right, have a good night.